Hey everyone, welcome back to our fourth and final science session. Today we're going to be talking about magnets and also about fire and how it works and doing some experiments with that. I hope you enjoy. Let's get right into it. Now we all know the basics of magnets. Every magnet has a magnetic field, and when it comes into contact with another magnet, they attract and can even defy gravity. They have a very strong force tugging them together. But what you didn't know is that every magnet actually has two distinct fields. It has a north side and a south side. And each of those fields, each of those sides, puts a distinct magnetic field. And a north side and a south side of a magnet will attract each other. That's what you see when the two magnets attract each other. It's the north side and their south side. Opposites attract. But same with the south side and north side. So this side of the magnet, we'll call it the north. This side of the magnet, we'll call it the south. So these two attract each other. But when a north side and a north side come into contact, they'll actually do the opposite of attract. They'll repel. Same with the south side and the south side. So if I take this is the north side of the magnet, we'll call it this side, north side, and this is the south side. The opposite side, encased in the plastic, is the opposite side. So for this side, if this is the north, the opposite side will be the south. And this is also the south because it gets attracted to the north. I know, confusing. But basically, if I take the south side of the magnet and put it into contact with the south side, it'll actually repel. These magnets this magnet will actually try to spin around so it can easily attract. But if you do it just right, you can actually see it pushing it away. If I try from this end, it pushes it away. It repels. It does the opposite of attract. Just like that. Now, the most common type of magnets or magnetism you'll see in real life is ferromagnetism. Now, only certain metals are ferromagnetic, like iron. That's the most common one we see. And that's why certain metals attract and others don't. Coins aren't made of a magnetic material, which is why, even though they're still a metal, they won't attract. So the next thing we'll be talking about is fire. Now, fire is one of those things that can be very dangerous, but at the same time is very fascinating. Now, there's something called the fire triangle, which is basically the three things that a fire needs to start. It needs heat, it needs oxygen, and it needs fuel. Fuel meaning something to burn. So with this, as humans, we've created this lighter that has all three of those things. We have a fuel, which is in the form of a candle and the wax on the candle. We have the oxygen all in the air around us, and we have the heat. So when we put out candles, we just simply puff a short, fast breath of air, and we can put the candle out pretty quickly. So a funny little experiment you can do is cut the bottom half of a plastic bottle and rubber band a Ziploc bag, and you can do the same principle of blowing out a candle really fast, but you have a little cannon. You can do it from far distances and practice your aim. Just like that. Now you might be wondering, if a quick, strong stream of air can put out a fire, why don't they use air hoses instead of water hoses on large fires? Well, that's because for larger fires, air actually provides oxygen, which, as we said before, is one of the causes of a fire. It's an accelerant. So putting more oxygen into those large fires will just make it worse and not actually put out the fire. To demonstrate this, how much a fire is dependent on oxygen, a little experiment. Oh, sorry. So we have this candle right here, right? And now we're gonna cover it, but oxygen is still coming through over the top. So we're gonna block the top. So now, knowing you oxygen is going to come in, and you can see the fire start to die. Oxygen is basically its food. So eventually, without the oxygen, it'll starve and die out. Once it uses up the oxygen inside the bottle, you'll see it start to dwindle, and eventually go out. So this next experiment is a little combination of today's topic about fire and our second week's topic about air pressure. So the first thing you'll need is a plate filled with water. I put blue food coloring so it's a little easier for you guys to see. Next thing you're gonna do is you're gonna light the candle in the center of the plate. Just like that. And then you're gonna cover that candle with the jar. The skinnier the jar, closer to the candle's diameter, the better it'll be. So I'm using a mason jar pretty close to the candle's width. Completely cover it. And you'll see as the candle starts to go out, the water will be sucked into the jar. Start to rise. just like that. The skinnier the jar you use, the closer to the candle's width, the higher it'll go. So the science behind that is the candle created lots of heat inside the jar, which caused the air molecules to expand and take up a lot of space. And when the candle went out, those air molecules cooled very quickly and compressed, leaving a lot of space and low air pressure above the candle. So that low air pressure inside the jar and high pressure outside the plate caused the water to suck in and go to the lower pressure area. On the topic of air pressure, we have another cool experiment you can do at home. What you'll need is a plastic film canister, fill it with a little bit of water. Then, using the Alka-Seltzer tablets we used in week 2 to make our lava lamps, you're gonna break half of it, and as soon as I put it in, I'm gonna cover it with the cap and put it upside down. Seal it tight, make sure no water spills out. And what's happening is the Alka-Seltzer tablet is releasing the oxygen bubbles in the water as they quickly flood upwards, creating big force, causing it to explode. Just like that. Pretty loud. And we ended with a bang. Thank you everyone so much for joining me with these science sessions. If you have any questions, please feel free to ask me. I really enjoyed making them, and thank you guys so much for watching.